So as you mentioned, yes, the team that we work on is the product security tooling team. So we're really focused on kind of like product security side, making sure that our products get shipped without vulnerabilities, or if vulnerabilities are detected later, that we can find those and report on them. So we've been working on this cataloging tool for about 7 years now. When I started at NVIDIA, the main goal was to catalog all of the projects at NVIDIA and find all of the open source. So that was kind of the start of this long journey. So I guess in a way we were kind of starting with a simplified form of SBOMs way back then. And since then, we have kind of evolved into having this registration portal. I'm not going to show all of that today. We're going to focus more on, what we're doing with VeX. But I wanted to give you a little bit of background on how we got to where we are today. So we have a registration portal where teams can come in and add in information about the products, including, the owner and different like who would need to sign off on any risk. Also, there is built-in reporting. There is a UI for putting in the interdependencies between the products and also for adding in third-party components as well. We track documentation in the tool, and then you can also kick off scans from the tool. We also have a platform where you can kick off scans in your pipeline, and you can send that reporting information or the scan results to the tool so that we can report on all that in one place. There's been other pieces built on top of this cataloging tool since it started 7 years ago. Every project gets a unique ID, and those IDs are actually used throughout the company to get other services. So if you want a cloud account, you actually need to have an ID from this catalog. So that's how we're able to get more and more buy-in and more user teams using the cataloging tool. We're working on also getting integration into distribution places as well. So like when we publish artifacts or when we publish container images, having checkpoints through the cataloging tool as well. So that's kind of the next step for the overall cataloging tool. Kaajol really is the SME on our team for container image scanning. And she works on this for the catalog tool, as well as the in-pipeline solution that we offer to all the teams, and for NVIDIA's NGC catalog. So you can go in, actually get container images from the NGC catalog, and all that scanning is done through a vendor tooling. You can see it actually right on the catalog, and Kaajol actually manages all of the tooling done on the back end to be able to do all of this scanning at scale. So having a catalog of all of these images means that if there is a new security issue found, we're actually able to kick off scans for all of the images that are in the catalog very quickly and add new configurations in case we need to scan for new things as well. With that, let's kick off this talk. So the talk today is really about kind of how we're doing a pilot program on VeX analysis for some of the container images that are on the NGC catalog. So we do have a subscription service for the NVIDIA AI Enterprise subscription that customers can actually access the subscription service to get access to container images that are more well-maintained and released at a quicker cadence than everything else on the NGC catalog. And we wanted to be sure to give the customers more analysis information on the vulnerabilities. So this is kind of a walkthrough of how we've started that so far, lessons we've learned, and things we need to do to kind of make that better. So we'll go through kind of the current state, the importance of SBOMs, obviously. Every customer now wants to know what is in my software, what am I getting, and what vulnerabilities are there as well. So we're doing this automated vulnerability reporting in-house based on from that cataloging tool, as well as the in-pipeline scans and in the NGC catalog. And then we are adding some prioritization enhancements to our reports. Of course, everybody would love to patch everything and upgrade as soon as things are available, but that's not always possible. So we do need to make sure that we can highlight the things that need to be upgraded as soon as possible. And we'll talk about kind of, if we're providing the SBOM and the list of vulnerabilities, this customer communication gap. So we definitely found that once we were publishing all of the scan results on the NGC catalog for our customers, that we were getting a lot of requests from customers asking, what are you going to do about this vulnerability? Or am I actually affected by this? So that's where we'll kind of break down how this problem started and why we decided to go down the VeX path. Then we'll talk about the life cycle of a analysis of, today we're really focused on the open source vulnerabilities. So when we scan the container image and we get the list of open source packages and then all the vulnerabilities that matched that, then we'll talk about kind of what the life cycle is as a new vulnerability is published or found in one of our scan reports, what the different options would be for the analysis and how we would go through those. And what we're actually showing our customers today that are using this subscription service. So you'll be able to see the difference between having a scan result without the VeX documents and one with the VeX documents. So you can see that we have like a score on the NGC catalog for the scan results. You'll be able to see the difference in the score and what we're showing our customers. And then how we're kind of moving forward with how to make this easier for developers. So as we scan the container images, it's a single artifact. And we found that a lot of the VeX analysis results would actually go from one release version to another. And we need to have a better way to do that mapping than our initial proposal of just having everything mapped to that single release artifact. And then a little bit more on the cataloging side, but being able to import these third-party provided components and how we can import the SBOMs and the VeX analysis from them as well. And then we'll talk about some next steps, and I have a little video to show. So I'll let Kaajol kick us off.
Hello, good afternoon, everybody. So I'm sure we've all know about SBOMs, but I just wanted to give some background on that as well. So an SBOM is a list of all of the third-party components and open source libraries that exist inside a software artifact. And this is very important for teams as well because it allows them to track and monitor all of the open source components inside of their software artifacts. So how do we get the vulnerabilities from an SBOM? So we scan source code, containers, and applications using a software composition analysis or SCA tool, which will generate the SBOM, and it will also pull up-to-date vulnerability catalog information from security advisories and vendor feeds, such as NVIDIA, GitHub, Debian, Red Hat. It will pull the vulnerabilities from there and then match components in the SBOM to known vulnerabilities. The tool will also be able to pull remediation guidance that has been published by the vendor, such as when a fix has been released for a vulnerability, for a vulnerability in which version it was released in, as well as if the vendor has said that this vulnerability will not be fixed. So we use the remediation guidance and the vulnerability analysis to build our own in-house reporting, as well as generate notifications for our developers on what their current vulnerability status is. So although we have the automated tooling to scan our containers and our code bases, the sheer volume of results is often overwhelming for our developers to know what to remediate first and what to prioritize for remediation. Even filtering on just the severity level of the vulnerabilities is often not enough to for developers to know what to prioritize and what to remediate. And so we often prioritize vulnerabilities based on if they have been exploited in the wild. So for example, we use the CISA KEV catalog, which is provided by the Cybersecurity Infrastructure Security Agency, and it is a catalog of vulnerabilities that have been known to be exploited in the wild. And we also get vulnerability information from our security research teams from our SCA tools, and they also provide information on vulnerabilities that have been exploited or have a higher exploitability risk in our product's context. Um, So now that the developers are working on reviewing the results and working on remediation, there is still a communication gap on how we relay this information to our customers. We often find that many of our customers are actually scanning our software artifacts with their own chosen SCA tools, and they're looking for justifications on detected vulnerabilities. This often leads product teams looking for answers to questions like who is affected by this vulnerability, what is the status of triaging this vulnerability internally, how do we communicate this to our customers, is this vulnerability a false positive, and lastly, how do we document this justification for our internal records. Existing security advisories often lack clarity on the true exploitability risk of a vulnerability, especially within the product context. So we need to be able to provide vulnerability justifications, such as false positives, exploitability risk, and triage status to our customers so that they are aware of our current risk status. So now I will pass it to Jessica to talk about our solution to this issue.
Okay, so it'd be great, obviously, if we didn't have any open source vulnerabilities in anything that we ever shipped, but we know that most companies are not able to do that at scale. So we actually, in I would say mid 2022 to early 2023, we were trying to come up with a better way to track the analysis of the vulnerabilities for all of our products, because the way that we used to do it was PSER team wanted to make sure that they had visibility into any of the analysis for these vulnerabilities if they were going to be shipped. And just so that if customers came back and asked questions about it, then we had the answer, right? Because the teams were doing the analysis and we needed to have sign off from the higher level business leaders to make sure that it is okay to ship with that risk anyway. So we used to track all these in tickets, but if the issue ever did get resolved and they upgraded the package, then that ticket just still sat there. Nobody really kept track of it very well. So we wanted to come up with a way to automate that or tooling to automate filtering those out of the reports so that we can continue to prioritize the vulnerabilities that we did not have the analysis for. But also if we wanted to have like a timeline or an expiration on, say, that exception, or if it was a false positive and we wanted to continue to remove it from the reports, we didn't have a great way to do that from the ticketing system. So we were designing a tool in like early 2023 to do this anyway. And then with the kind of like industry moving towards VeX, it became very obvious that we should incorporate VeX at that time as well to get all of our developers using the same terminology that industry is trying to get us all to use anyway. So we added VeX to this tooling, and the VeX tool became used. I think we did our first release in June of 2023 last year. And then we were able to actually publish some VeX documents for customers towards, I believe it was October, November of last year. So, the goal really is that all of industry using VeX could have a shared terminology for the analysis of those vulnerabilities so that all of our customers can understand if they're affected by a vulnerability or not. So we decided to move forward using Cyclone DX for our SBOM specs, and at the time last year, since VeX was supported in Cyclone DX as well, we moved forward with using that as our VeX spec for OSS vulnerabilities as well. But these same lifecycle pieces really apply to any VeX spec that you use. So if you think about when a new open source vulnerability is published, we always want to know, like, is this vulnerability found in our product? So the first thing would be, is the package in the SBOM? So yes, if it's in the SBOM, then we're going to go through the triage process. And because we use software composition analysis tools to create the SBOM, then there could actually be some false positives there, unfortunately. So the package could be in the SBOM, but maybe that open source, like that SBOM has an incorrect entry of that package, or the version was incorrect, or there was a CPE mapping error, which we do find with our tools sometimes as well. So maybe the vulnerability is mapped to the wrong package, or there could be a language mapping error. So We do have the option to put in false positive for the analysis of a vulnerability. These entries here, OSS not present, CPE mapping error, language mapping error, are not standard for the Cyclone DX spec, but we have added those ourselves as things that we have found are common issues with false positive. Then if it is not a false positive, the package is in the SBOM, then the next thing would be, are we affected by that vulnerability, right? So we want to see if there are mitigating factors in place. Maybe that chunk of the code is actually not present, or it's not reachable because we don't use that code path. Or it requires a specific configuration, or you're protected by a specific configuration, then you do have options to state that. And remember, in this case, this use case, we actually have this container image and it's already published. So we'd want to know, we want to be able to tell our customers that they're not affected by this vulnerability. Obviously, if we can upgrade, we should upgrade, and we can try to upgrade that open source package for the next release of this. But we also would like to inform our customers if they're not affected by it today. Then if they are affected by it, there could be cases where maybe there isn't a fixed plan because it doesn't have the vulnerability in the environment that it's used in could be low enough severity that we're not going to fix it. Or we have a workaround available, so we'd like to be able to document that for our users. Or we do have an update and they should update to this next release version. So you can see that in the second to last column, the affected column, if there is a new release, or if there's not a new release yet, and we have like the fix not planned, or maybe there's a workaround available. Once there is a new release available, then we can add in that they do have an update and you should update to this latest release. So once there is a release, then if we've upgraded the OSS package, then that vulnerability should technically fall off of the vulnerability list, right? But in cases we do patch those vulnerabilities specifically in the code base, so then you could state that that is resolved. And we do actually work with some vendors that manage open source code for us because we need to lock to specific versions for long-term supported products, and those patches then are applied by those vendors. So we need to be able to track that these were patched in those releases. So with our pilot program, we were able to add the VeX analysis documents to the NVIDIA AI Enterprise subscription container images. So you can see on the left-hand side what it looks like if the person is not using the NVAIE subscription. So they would still be able to receive the container image, but they don't get the VeX documents, and they don't get as quick of upgrade available for those container images. You can see under the scan details, there is a little grade there. So this one has a C because it has, I forget the full scoring rubric, but I think it's like 3 or more packages that have at least one high or critical vulnerability. And then on the right side, we do have the VeX analysis added to this container image. It's this exact same container image, but since the VeX documents have added the patched status or the false positive or not affected status, then those critical or high vulnerabilities that you're affected by, or that you're not affected by, actually fall off of the scoring page. And you can see where you can download the VeX documents. And right next to that VeX documents, you can see where you'd be able to check the box for include no risk vulnerabilities. So you'd be able to see all of those higher critical vulnerabilities that we added VeX documents for. And as part of this pilot program, we started with just looking at the critical and the high vulnerabilities for creating the analysis for publishing for our customers. So when we started this, we were on a very tight timeline. And so the goal was really to be able to, for the enterprise customer subscription container images, have the digest of the artifact that we're about to release. So that final container image. And then we want to be able to add all the VeX analysis for the vulnerabilities to that specific digest, right? So we know that that artifact is unique. But now moving forward, we're finding that when you go from one release to the next, a lot of those patched vulnerabilities are still patched in the next release. We don't go back and remove the patches, and anything that is potentially a false positive or not affected is most likely still the same VeX analysis, or has the same analysis for the next release as well. So also what we found is that you needed to have that specific digest for the uh, artifact that you're going to publish before you could go create the VeX, which really makes this like you're still tracking everything in spreadsheets until you're ready to publish it, right? So we wanted to be able to do this at an earlier stage. So if you think about how the development life cycle works, when you decide that you're going to do, say, release X, and this is really a user flow for a container image. So we have release X, we've tagged it with, say, that release ID. And when we do a build, we get a new digest. When we scan that artifact, we really map all of the reporting results to that digest. So it's to that unique identifier of that artifact. And so we report all of the open source packages and the vulnerabilities that are associated to that unique identifier of that artifact. Then the teams can go in and actually add the analysis. So that would be that VeX circle there. They can go in and add the analysis for any of the vulnerabilities, and they can submit those for pre-approval. And depending on what category they pick for the analysis, it has to go through a different approval workflow. So if something is not affected or false positive, then that workflow is sent through, that approval goes to like a security expert on that product team. If it is something that is affected and they're not going to fix it, then that needs to go to somebody, a business leader that can sign off on that risk. So depending on what the category is, it goes to different users for approval. So once they've created the analysis for the vulnerabilities that they're ready to filter out of the report, then that gets added back to the report, and those vulnerabilities will get removed from that report. They actually get added to another report, so you can still go see them. But then that can bubble up any new vulnerabilities that they don't have analysis for that are published while they're still in the build process. So they could potentially decide that they're going to go and fix some of the, upgrade some of the OSS. And so they're going to go do another build. So they do another build. It's a new digest, but it's the same tag. So we scan that artifact. Again, we scan it by digest because we have to have that unique identifier to map all of the reporting information to for that specific artifact. So all of that goes into the report. Now the reporting tool can talk to the VeX tooling and actually sync it by the tag ID, so it can filter out any of those vulnerabilities that are still in the report, but now we already have analysis for them. So we filter those out, and then the team can go in and create any new VeX analysis docs that we need. Once we're ready to publish, then the release artifact, so the one that they're ready to publish, we have that digest for that final release artifact. It goes through a final approval where we lock all of those VeX documents to that final digest, and then we're able to publish that set of VeX documents. If there's any new vulnerabilities published later, then all of that goes into our reporting tool. The team can come in and see those, and they can create new VeX documents. It can go through the approval process, and it can be published again. So similarly, when we're moving from one release to the next, then we want to be able to copy over a set of those VeX documents from one release to the next. So after we do the scan and we report on all those vulnerabilities, then the team can go into the VeX document tool. They can clone from a previous release, and they can pick which categories they want to clone. So maybe they just want to clone the false positives and the patched VeX analysis docs. So they can clone all those to the next release, and they'll start filtering out of that report. And they'll go through the same process they did as they continue going through that development lifecycle. So moving now to, this is really for OSS because all of our scanning tools, detect OSS, but we don't have scanning tools yet that can detect the third-party provided components. So as part of our cataloging tool, we also have this Connects UI, which allows teams to come in and build out the dependencies of a specific program. So you can build out dependencies from, they basically have to register, each of these programs separately, but you can register third-party provided components as well. And then you can upload the SBOM for those third-party provided components, and you can upload any VeX documents. Today, we actually don't get VeX documents from any of these third-party provided components, but as we move forward and we're able to, as an industry, all be sharing this information, then we could also upload those. So we can then collate all of the SBOM information whenever we need to produce an SBOM for an entire product. And we can also collate that VeX information and quickly review that to see if those VeX analysis apply to that overarching product. So we know that, for false positives and for patched VeX analysis, those would likely carry forward. Some vulnerabilities the analysis at a lower level dependency may not be the same as what that analysis should be at a higher level. So those will still need to be reviewed. Okay, so some next steps. So as we are using the VeX tooling to grab all of the analysis information, we often have the same vulnerability found in multiple products. So we'd like to be able to give some sort of VeX hints, right? Like if we've already done analysis, some teams have done analysis on this vulnerability, we want to be able to provide that information to somebody else, a different team that's coming in and looking at that vulnerability so that they can potentially reuse some of that research that's been done by other teams. So that's what the VeX hints is all about. And then we also know that for many of our containers, they're built using the same base container image. So we'd like to have like a bulk blanket analysis type of tool in the VeX tool, where you could say, for this base container image, I've done the analysis on the base container image, and these are all the VeX analysis docs that I would like to associate to this base container image. And we could group those, give them a name, and then whenever a team scans a container image built on that base container image, they can come and tag it, and they could then grab all of those VeX analysis so that they can reuse those as well. As I mentioned earlier too, we do have some vendor agreements where the vendor patches some of the open source for us at certain versions. So we could also use that in the bulk blanket analysis. So you could add in all of the VeX analysis for these patched vulnerabilities and specify the vendor version of when we got that release. And then we could add those tags to the container images that are using those versions and be able to pull in all of those VeX analysis. We also have found, like with the third-party provided components, we would love to be able to import security bulletins, especially now that we're seeing that like NVIDIA sometimes is slow to add the scores for the vulnerabilities. If we could import the security bulletins into our cataloging tool, I think that would really help with our third-party provided components. So as all of industry moves towards, CSAF maybe for bulletins, and that would really help us be able to import that. And then we do have teams at NVIDIA that are working on a CVE analysis, like AI workflow that should be able to help us kind of provide more like VeX hints, right? So let me play a little video for you. This was something that was announced at NVIDIA GTC conference this year.
Enterprise applications are composed of many software containers, each involving a complex set of dependencies. To triage a container for vulnerabilities, hundreds of pieces of information need to be retrieved, understood, and integrated. A tedious process that can take days. Let's look at how we use generative AI to shorten the process to mere seconds. This is Agent Morpheus, built using NVIDIA Inference Microservices, Nemo Retriever, and the Morpheus SDK to create an event-driven, retrieval-augmented generation application. A fine-tuned large language model scans the container and generates a customized checklist that matches a standard security VeX document. The agent executes many perceived reason act loops. Under the hood, it's like the system is talking with itself to reason through the analysis. This continues until the application examines the full checklist. Within seconds, a summary is presented to the human decision maker to determine if the container can be published. Thousands of these Morpheus AI copilots are used by NVIDIA's own engineers, continuously scanning vast amounts of software in an ever-changing landscape of security threats.
Okay, so we're really excited to work with the team at NVIDIA that's working on this. They're also working on having this available for customers as well. I don't know the date yet. They did just publish a blog post in late May called Applying Generative AI for CVE Analysis at an Enterprise Scale. So it's not on here because we had to gave our presentation we uploaded it before then, but you can find that on the NVIDIA developer website. And then the goal is for this model to be available for teams to, or for customers to test out on the build.nvidia.com website in the next couple months. So they do have that on the roadmap. One other thing I wanted to mention is we do have customers that scan with different scanning tools than we use, right? And so they'll bring different reports, and often they'll have some vulnerabilities listed in there that we did not find using our scanning tool. Often it is because there are false positives because the mapping to the distro vulnerability information or bulletin is not done through, like, they're using NVD instead of going through those security bulletins. And so we're planning to use Agent Morpheus to do that as well. So once we can provide that SBOM, we can provide the scan results from a customer and be able to more easily get all of those details or that overview of the customer scan report. Okay, I think that's it.
Thank you.
Sorry, I did go over.
Time for a few questions. Please come up to the standing microphones. Oh, okay. Oh, there you are.
Thank you for the talk. My question would be, so you're having the digest, do you actually put all the hashes into the SBOM
The hashes.
of the components that you, or of the releases that you create?
Yeah, so we do, the hash is the digest is of the container image. So when we create an SBOM for that container image, we do put the actual digest of that in the SBOM. That way it's easier to make sure that you have the SBOM for that unique artifact, right?
Yep. And do you also collect for the things that are within the image hashes that you then can associate with the SBOMs that people uploaded to the ConnectX?
I think so. We are getting the SBOMs from the vendor tool, and I don't remember if Anchor actually has a hash for each of those components. Yeah. Okay.
Thank you.
I will say that our VeX documents don't map all of those hashes yet, so we are working on adding those in.
Other questions? Okay. Oh, sorry.
Sorry. One little question. Based on your diagram, you starting from the SCA. How do you trust SCA results?
Well, I mean, unfortunately, I don't think we have other options at this time.
Okay.
So we have to trust SCA results. We are working on trying to get all of our teams using a set of approved base container images, and I think that will really help. Because once we have a set of approved base container images, we can focus on getting the SBOMs for those base container images to be more precise. And then we can have the application SBOM comparison on top of that. But we do know that there are some missing components in the SBOM results, unfortunately.
But I guess you have a source code and all those components in the diagram. Then only part you don't have the like a list of the compiling list or something, or do you make the whole things to the SCA?
Yeah, so we scan source code and then we scan the container image artifact separately. We
Okay.
actually use two different scanning vendors because we found that, the different scanning vendors are better at the different artifact
I
types.
see. Well, it seems to me if you have a white list, you don't have to make SCA for the whole thing. So
Oh, if we have like a list from the team.
okay, I see.
Yeah.
Thank you very much.
Okay. Any other question? Okay. Thank you, and give them another round of applause. Thank you.